Hi friends, see Newton's laws of motion. In part 1 we discussed about second law and also we derived one equation also. Okay, we derived one equation. Okay, now see here, let us go into the last part, that is part 2, that is Newton's third law of motion. Now first of all, what is Newton's third law? Third law is simply you can say as action is equal to minus of reaction. That means for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction, or simply you can say action is equal to minus of reaction. Why this minus? Minus indicates that the resultant is in opposite direction of the applied force. Okay. Now let us explain very clearly regarding third law by using some blocks. Now on the board you can see there are three blocks, M1, M2, M3, resting on a ground surface. Now a horizontal force, for example F, is applied on body M1. Now in such cases, how to calculate the net common acceleration, how to get the common acceleration and also the contact forces between M1, M2 and also M2, M3. Okay, right. Now there is a simple method already I have discussed before, how to get A net when bodies are attached together. When bodies are attached together, see, A net, common acceleration in this direction along the applied force is given by F net by M net. So common acceleration A net is equal to, what is the total force acting F by what is the total mass M1 plus M2 plus M3. So this is the acceleration of the blocks, that is M1, M2, M3. This is also called as common acceleration. దీన్ని మనం కామన్ యాక్సిలరేషన్ కూడా చెప్పొచ్చు. ఓకేనా? సో ఏ నెట్ ఈజ్ ఈక్వల్ ఏమైంది ఎఫ్ బై M1 plus M2 plus M3. క్లియర్? రైట్. నౌ ఇదే ప్రాబ్లంకి మనం ఏం చేద్దామంటే we also find out contact forces. Contact is nothing but normal force is a contact force. So how to calculate normal force between these two bodies, that is M1, M2 and M3? See here. Now F1 is acting on block M1. Now what M1 will try? M1 will try to give some force on M2. Let it be N1. In the same way, according to Newton's third law, M2 will apply on M1 as same force N1. This is the contact force between M1 and M2. Now coming back to M3, I'll put it here, M3. So on M3 what happened? Let the normal force contact be N2 and this will be giving again same N2 for the second body. So this is how we will be explaining the third law of Newton. Contact force, see, contact force or forces between the blocks can be calculated by Newton's third law. Now I assumed in the above figure, between M1 and M2 let the contact force be N1, between M2 and M3 let the contact force be N2. Now see here, already we got net acceleration, total force by total mass. Now how to get the, a normal force N1? See, very simple here. What is the force acting on this block? M1, F. So M1 will try to push M2 with a normal force of N1. And same equal and opposite N1 again gives to the M1 block. Now here the normal force can be, see, positive side this side. This is positive side and this is negative side. Clear? This is positive and that is negative. Now we will try to calculate here N1. F is the total force acting in this direction on the block M1. So F minus in this direction. What is the force? Normal force you assumed. N1 minus N1 is equal to MA. So the force, what is the mass acting? What is the total mass here on the first body? M1 and A. A is the common acceleration. It is got by F net by M net. So finally I will get F minus N1 is equal to M1A, or F minus M1A is equal to N1. This is how we will get the contact force between first block and second block. Same way you can find the contact force N2 between second and third block. How you will get? Come back to the last block. See, the only force acting on the third block is the normal force. See, only N2. So, N2 force acting on the third block is equal to M into A, that is M3 into A. So, this is the contact force acting on the block, second block and third, because equal and opposite reaction. So, N2 is equal to M3 into A, where A is what? A net, F net by M net, that is F by M1 plus M2 plus M3. Now, same thing we will try to understand by giving a numerical. We will give some values and we will find out for the above problem. See, for the above one, I will give some values and I will try to solve. See here. For example, let us assume 1 kg M1, M2 2 kgs, M3 3 kgs. Let us assume 1 kg, 2 kg, 3 kgs. Okay? So 3, 4, 5, 6 kgs. For example, let us assume say some 6 newtons. Let us assume some 6 newtons of horizontal force is acted upon body M1. A small numerical to understand better way regarding the contact forces N1 and N2. Now in this case, what is acceleration? Common acceleration. A net is equal to F net by M net. So common acceleration of the 3 blocks in this direction along the force is equal to total force. What is total force acting? 6 by what is total mass? M1 plus M2 plus M3, that is 1 plus 2 plus 3, that is 3 plus 6. So what is the value? 1 meter per second square. So these 3 blocks will travel with same acceleration, common acceleration, that is 1 meter per second square in this direction. Now, secondly, what are N1 and N2 you have to calculate? Let us first find N2. We have already given the equation here. What is N2? Normal force between second block and third block. That is nothing but M3 into A. What is M3? 3 kgs into A. What is acceleration? 1. That is 3 newtons. So this is the normal force, contact force between second block and third block. Now let us find out the normal force, that is contact force between first block and second block. How to calculate? See, between this first block and second block, what is the normal? We have assumed N1. So this force, this direction is positive and this direction is negative. If I apply force here, F applied force minus normal force acting between second block and third block is equal to M into A. What is M here? Mass of the first body into common acceleration. So force 6 newtons minus N1 we don't know, you have to find out. This is the contact force between second block, first block and second block is equal to M1, mass given how much? 1 kg into what is common acceleration? 1. So 6 minus N1 is equal to 1 or 6 minus 1 is equal to N1. Therefore finally what is N1? 6 minus 1 and the 5 newtons. So these are the contact forces between the block, first block, second block and also second block and third block. So this is how the problems are solved in MSET and NEET examinations. These are very very important techniques. You have to adopt this one and you have to try in the examinations. Okay. So this is about the Newton's third law regarding block problems, that is connected blocks M1, M2, M3, so on and so forth. So any connected blocks you can calculate by A net is equal to F net by M net. So after this case we will go to the last case, that is in Newton's laws, that is for example sometimes you will be asking constraint motion. What is constraint motion? Constraint motion ante enti? What is the definition of constraint in English? Constraint means restriction to any one side, either left side or right side. So constraint motion means you are restricting the direction of the motion. For example, let us take the small example of outward motion. Let us take the example of outward motion. In outward motion you have a pulley ఉంటుంది. అదేవిధంగా ఒక స్ట్రింగ్కి 2 బాడీస్ అటాచ్ చేసి ఉంటాయి, M1 and M2. ఫర్ ఎగ్జాంపుల్ ఇది M1 ఇది M2 అనుకుందాం. In outward motion you can see same string means, see string if it is same tension it won't change. So let it be tension T. Okay, tension T. because the string is same, tension is same. But here we already know the acceleration will be same for this and this. But in this case, what I'll try is, we'll see that we don't know the acceleration value. Let m2 is greater than m1, then the block will come down. Let this be at a2, and this block will go up. Let this acceleration be a1. For instance, already I know the value here, but what we'll do is, we'll try by using constant motion to solve a1 and a2. Okay? So what I'll do is, you can see constant motion, the formula is sigma vt is equal to 0 or sigma at is equal to 0. Sigma means what? v1 t1 plus v2 t2 plus v3 t3 plus so on and so forth. Here v1 t1 plus v2 t2 plus v3 t3 plus dot vn tn is equal to 0. Here v is velocity, t is tension. In the same way, when acceleration is given also you can apply. That is sigma at is equal to 0. Dot product of acceleration and tension. a1 t1 plus a2 t2 plus a3, see here I am writing here, a1 t1 plus a2 t2 a2 a3 t3 plus dot a and tn is equal to 0. Now I will apply this formula here and I will try to solve the values here. See here, now here we have to calculate acceleration here, not velocity, because it is asking acceleration here. Now I will apply here, see, sigma at is equal to 0. So here only two items are there, that is a1 t1 plus a2 t2 is equal to 0. Now what I have considered, one is in upward direction acceleration, another is in downward direction. Okay. Now see here, tension here, t is in upward, acceleration also in upward direction. That means both are in same direction. What is the angle? Theta is equal to 0 degrees. So here if you apply here, a1 dot product mod a mod t into cos theta. So a1 t1 cos 0 1. Okay, same direction. Therefore angle is equal to 0 degrees. Plus here next one, right here. Now in this case acceleration you have to find out. We are applying the constant motion. a1 t1 plus a2 t2 is equal to 0 here. Now see here, tension and acceleration both are in same direction, therefore angle is 0, cos 0 1. Therefore a1 t1 into 1 plus, here you can have acceleration is downward, tension is upward direction. So cos 180, angle is 180 minus 1. Therefore a2, okay, t2 cos 180 minus 1 is equal to 0. Therefore a1 t. See, tension is same here. You need not write t1 t2. Same tension because string is same. So you need not write t1 t2. String same అయినంత వరకు tension మారదు. Therefore string మారితే tension మారిపోతుంది. So same tension. So a1 into t plus into minus a2 t is equal to 0. లేదా a1 t is equal to a2 t. t cancel. So what is the answer? a1 is equal to a2. That's what I told in the beginning. In this case, outward motion, acceleration a1 and a2 will be same. One is in upward direction, another is downward direction. So in this fashion, you can find out the velocities or acceleration of any block or any complicated problems also by using this constant equation. Now let us go to the next case in this type. That is, for example, sometimes in MSET they will be asking, suddenly if a string is cut or a spring is cut, what happens to the, acceleration of the body? This is the last one, second last one. That means here, case 1, suppose a string is cut. Second one, spring is cut. Spring cut చేసిన వెంటనే immediately, not after some time, immediately, not after some time, after half an hour or 1 hour. He will be asking, when the spring is cut, immediately what happens? Acceleration. Immediately tension ఏమవుతుంది? ఇవి కట్టాలి మనం. So one thing you have to make in your mind, see, I'll give a small example also. This is string. Let a block having mass m. Now for this I am attaching a spring. Let the mass is 2m. A small example. Now this is string. This is tega. And this is spring. Spring. SPR. Now what you have to make in your mind is, when a string is cut, tension will become 0 immediately. When a spring is cut, spring force will be 0. These points you have to make in your mind. String cut చేసిన వెంటనే immediate ఏమవుతుంది? Tension 0 అయిపోతుంది. అలాగే spring cut చేసిన వెంటనే immediately spring force 0 అవుతుంది. These are things you have to make in your mind. Now how to solve the problems? How to get acceleration? See, these are the conditions. First condition, number 1. What you have to do is, before cutting string or spring given in the problem, first you have to calculate the balancing forces for the bodies given on the board at equilibrium. So first I will consider for first block and then for second block. Okay. Now first block, for example here, string, let the tension be T. Now here spring force Fs, upward, weight downward direction, W is equal to mg, and here again spring force Fs, and additional spring force will get weight also again here mg. Now we will find out the equilibrium forces for each and first for this block. First block. For first block, what are the equilibrium conditions? Forces acting. ఒకటేమో Fs, ఇంకోటేమో weight, పైకి tension. చూడండి. So here when it is in equilibrium, first one, see, T is equal to downward ఏ force act అవుతుంది బాడీ మీద? spring force Fs plus weight mg. equation 1. Now consider this block. ఈ బ్లాక్ తీసుకోండి. ఈ బ్లాక్ మీద ఏంటి పనిచేస్తున్నాయి? see, సెకండ్ బ్లాక్ ఏంటి ఇక్కడ? 2m. దీని వెయిట్ కిందకి W equal mg, దీని పైకి స్ప్రింగ్ ఫోర్స్. నా ఇక్కడ దీంట్లో చూడండి ఏమి యాక్ట్ అవుతున్నాయి. when this body is in equilibrium, what happens? spring force Fs, upward direction, is equal to weight of the body, that is mg. mg అంటే 2mg. equation 2. Now put this equation 2 in equation 1. What happens? T is equal, what is Fs from here? 2mg. So 2mg plus mg ఎంత అవుతుంది? T is equal to 3mg. So finally I have calculated tension and other things when the body is at rest position. Now you apply the conditions. In first case what I will do is, let the string is cut. First case ఏం చేస్తాను నేను? string కట్ చేసి అనుకుందాం అంటే ఇది. let this is cut. First case string కట్ చేసిన వెంటనే ఏమవుతుందని చెప్పాను? tension 0 అవుతుంది. When string is cut, what happens? Immediately tension 0. So tension 0 అప్పుడు what are the forces on this block? See, force on this block ఏం యాక్ట్ అవుతున్నాయి? This is the block M mass, పైన టెన్షన్ 0 because string కట్ చేస్తాం. సో టెన్షన్ కింద యాక్ట్ అవుతుంది ఏంటి? ఇంకా కింద ఏంటి యాక్ట్ అవుతుంది? స్ప్రింగ్ ఫోర్స్ అండ్ ఆల్సో ద వెయిట్ mg. So what is the total force acting weight now? Tension is 0. Total force is this thing, Fs plus mg. What is Fs from here? You can see what is Fs? 2mg. So 2mg plus mg amma ఎంత అవుతుంది? 3mg. This is the weight acting downward. Now what is the acceleration of this block? ఈ weight ఎక్కువ downward, ఎక్కువ weight ఎక్కువ ఉంది కదా పైన 0. So here acceleration is equal to F by m, that is force అంటే 3mg by mass of this block m. So what is the value? 3g downward direction. That is the acceleration of the block when string is cut. Now coming to the second block. Now come to here. ఈ రెండో బ్లాక్ ఎంత మాస్? 2m. సో ఇక్కడ ఇది కట్ చేయాలి, ఇది బాగానే ఉంది. సో స్ప్రింగ్ ఫోర్స్ విల్ బి దేర్ ఆన్ ద టాప్ Fs and weight will be downward. So in this case what is Fs? 2mg. What is Fs? 2mg. So upward force is 2mg. What is downward weight? 2mg. So what is the net force acting on this one? 2mg minus 2mg. 0. So force, net force is equal to 0. What is acceleration? 0. So when a string is cut immediately, for the first block, acceleration will be 3c in downward direction, and second block, acceleration is 0 because the weight is balanced by spring force. So net force is 0, acceleration is equal to 0. Clear? Now what I will do is, second case and last case. When spring is cut, what happens, we'll see. Same thing, I will cut for now spring. Okay? Copy? Very good. Now we'll go to the second last case. First case అయిపోయింది కదా, ఏం చెప్పుకున్నా first case లో, when string is cut. Now string will be there. Now I'll cut spring. String అలాగే ఉంటుంది. Now I'll cut spring. Okay? Now what happens is I'll cut spring. Second case. That is second one, I'll cut spring. ఇందాక ఏం చెప్పాను మీకు, స్ప్రింగ్ కట్ చేసిన వెంటనే immediately spring force becomes 0. So when you cut immediately, what is spring force? 0 here. So for this one you apply. For this block what happens? This is 2m. This is weight. And upward ఏమైంది? Spring force 0, no force on upward. So the only weight acting what? Downward. How much? 2mg downward weight force. Now what is the acceleration? Acceleration is equal to force. F is equal to m, force by, that is 2mg by mass. 2m cancel. What is g? So acceleration of this block will be g in downward direction. Okay? Now coming back to here. First block what happens? Tension as it is. Here when spring is cut, what happens? Spring force becomes 0. So here Fs will become 0, but weight will be there. What is the weight here? mg. Okay? అప్పుడు ఎంత అవుతుంది ఇక్కడ ఫోర్స్ చూడండి. Already tension ఇక్కడ calculate, tension is equal to 3mg. So 3mg is larger than mg. So net force will be in upward direction. That is 3mg minus mg. That is 2mg. So this is the net force in upward direction. So what is the acceleration? I'll write it here. So acceleration of this block, okay? Acceleration of this block is given by force. What is the force in upward direction? 2mg by, what is the mass of this block? M. So 2g in which direction? Upward direction. 2g in upward direction. So this is how you will be calculating the values when spring or string is cut. Immediately these are the values of acceleration. You can apply this one for any type of problems. Okay? Right. Please copy it. Now last case in Newton's third law, that is rocket propulsion. This is the last case of Newton's third law, rocket propulsion. That means, for example, see, we all know the principle of rocket. In this what happens? The fuel will be burning down, fuel will be coming out. Okay, this is action, and rocket will be going in upward direction. This is the thrust acting on the rocket. Okay, so in this case what happens? It will be going with some acceleration A. So what is the thrust? Thrust F, thrust force upward direction minus weight is equal to m into A, or thrust force acting on the rocket is equal to W plus ma, or you can write as mg plus ma. So this is the thrust force acting on the upward thrust acting on the rocket. This is one formula. Second formula, the fuel is giving out continuously, combustion down. Okay, now this combustion fuel, that is nothing but rate dm by dt. This is the rate of mass of fuel giving out. dm by dt అంటే ఏంటి? Rate of fuel mass. Rate of fuel mass. ఇక dm అంటే ఏంటి? ఎంతైతే మాస్ ఫ్యూయల్ కింద బయటకు వస్తుంది, that is called a dm, mass of the fuel with respect to time. So dm by dt is called the rate of fuel giving out. So another formula also having for the rocket principle is thrust, upward thrust is equal to horizontal velocity, the velocity with which it is going, horizontal velocity into dm by dt. Very, very important formula for solving numericals in rocket problems. ఇక్కడ ft అంటే thrust, upward thrust acting on the rocket. u horizontal force, it will be given. And dm by dt అంటే ఏంటి ఇక్కడ? Rate of fuel coming out. Rate of fuel coming out. dm, mass of the fuel, dt time. So when you multiply with this horizontal force with dm by dt, you will get again thrust acting on the rocket. Or one more formula for thrust is ft thrust is equal to mg plus ma. You can apply here, see all of you. You can apply here and you can solve the problems finally. Okay? Okay students, so this is how we will be applying the rocket principle formulas, upward thrust and also dm by dt formula, horizontal force. These two formulas are very, very important in rocket problems. Okay? And this is the end of Newton's laws of motion. We will be meeting in the next chapter, that is work, power and energy. Okay?